Ever since my journey into non-dualism, I'm puzzled by this line from the poet Rumi. You're not a drop in the ocean, but the ocean in a drop. This paradox that we are both the whole universe and at the same time an infinitesimally small drop located in space and time is something I can ponder on daily in a philosophical way. But what would the world's most cited neuroscientist have to say about it?
Yeah, when I was born, I didn't have any notion of me. And I didn't have any notion of mother. From my point of view, this was just some oceanic universe. So how on earth then do you conceive of a boundary that is intimately porous and glues you to the soup, of which you are a part, but also at the same time distinct?
Biology cannot tell us how from the primordial soup cells emerged. And neuroscience cannot tell us how from brains selves emerged. But what if there is a principle that can at least describe both of these mysteries in a mathematical accurate way?
The trick is you effectively use statistics or probability theory to define the minimal conditions that allow for a statistical separation, a veil, something that is shared between the observed and the observer, but is not the observed or the observer. We need a physics of observation. You could glorify that and say a physics of sentience. And that's the role of the Markov blanket.
Karl Friston is famous for the free energy principle, a mathematical way to describe what living systems do within their boundary. And that boundary, whether it's a cell or a conscious being, is mathematically described as a Markov blanket. Though I was highly interested in all of this, I was specifically interested in his metaphysics.
Space and time, as we talk about them and read about them at school or in physics books, are just stories. So the notion that you are you, the minimal selfhood, or in fact the selfhood itself, is just another story under the free energy principle. I'm certainly not a materialist. No, the whole point of the free energy principle is that there cannot be a fully measurable world. If there was, you would be part of that world, and by the principle of unitarity, you would not exist.
I'm just curious, how is that in your theory? If the Markov blankets gets bigger, can there be Markov blankets within the Markov blankets, and are there selves within a bigger self?
Yes.
All right. A very warm welcome to the Essentia Foundation's YouTube channel. I have the pleasure and honor of sitting in the study of Professor Karl Friston. Thank you very much for having us here in the first place. It's wonderful to be here.
Oh, thank you for coming. It's my pleasure to be here.
Yeah, and in the very room where I think you made tremendous contributions to the field of neuroscience. You're a professor of neuroscience at University College London. And just to name some of the neuroscience jargon of the things you invented, the statistical parametric mapping, voxel-based morphometry, dynamic causal modeling, these are all fundamental innovations in the field of neuroscience. But in particular, you're known for the free energy principle. Sort of opening question I have for you, and we briefly discussed it before we sat down, is this idea that many people in thinking about the mind and brain still have the idea that we perceive the world somehow as it is, and only when there's something wrong with our brains, we make mistakes and we see a different world, because there seems to be consensus reality that's the same for all of us. So somehow we think that we see the world as it is. And your work makes very clear that that's not the case. And it brings us back, in a sense, to this old idea of Plato, of being in a cave, in a sense, right? We have to do with the mirror images of the world, and we cannot see the world directly. I was just curious how you see that sort of that metaphysical shift that has happened in neuroscience, because I think it has happened during your career or was already happening. But very nice to hear your reflections on that, sort of that metaphysical shift.
Well, I think it's nice you start with Plato. So I often, when asked, how would you describe the free energy principle? I say there's a high road and a low road. If you want the physicist's road, and I suspect we will be talking about the high road entailed by a physics of sentience, physics of sentient behavior. The low road, though, would, I think, begin with Plato. And it would, and I mention that because, in a sense, the free energy principle is just the denouement of a long story, a story that you could trace through Kant, Helmholtz, great psychological thinkers of the 20th century, people like Horace Barlow, Richard Gregory, perception as hypothesis testing, for example, analysis by synthesis, through to innovations in machine learning. Indeed, people like Geoffrey Hinton and Peter Diane built a Helmholtz machine, and the fundaments and the principles that underwrite that kind of artificial intelligence, or at least machine learning, are, I think, a testament, or the success of those kinds of applications, I think, are a testament that that's the right track. So sometimes people like Anil Seth and Andy Clark sort of draw a distinction, which I think you're speaking to, between this inside-out view of the brain, where the brain is a constructive organ. It's our percepts, are constructs, are fantasies, hypotheses, models, illusions of a certain kind that are brought to the table in order to explain the sensorium. So this view of the brain as effectively a statistical organ, you can cast this kind of observation, this kind of measurement or sampling the world as inference. So we can think of the brain, and in fact one could generalize this to lots and lots of things, but particularly you and me and our brains as statistical organs that are in the job of finding the best explanation for the sensory data at hand. So this somewhat contrasts with a 20th century view, which would be more the sort of outside in, that somehow we extract information about some metaphysical reality out there and make sense of it. That's not, I think, the 21st century view, and I would argue it was not the 19th century view. So, from my point of view, things are just steering a steady course over the centuries.
Very interesting. And you mentioned the Helmholtz. I think that's a nice sort of point to start historically, because he was the first to sort of, or one of the first to make the point that it cannot be that we mirror the world in our brains. I mean, even optically, that was new to me in researching all of this, and also said it to Anil Seth in the interview, that just the optics of the lenses in our eye are not that good, sort of just rendering optically the world we see. And so it has to be this generative model. But he was the first to come up with that, right? The Helmholtz machine. And then, but it didn't enter neuroscience that early, right? I think it first his ideas were sort of adopted in cybernetics, or I mean, just nice to sketch his idea of the Helmholtz machine and what it was.
Right. Well, that's interesting you bring up cybernetics, which has a very similar flavor, but clearly from a different technology and a different kind of science. So I think Helmholtz's gift was this notion of unconscious inference, that, we perceive, you have to have it on the inside before it is seen or measured or observed. So it's something that has to be there in our brain before you can recognize something or classify something. One could argue that his ideas, with some nuance, themselves inherited from Kantian thinking, who himself could be traced all the way back to Plato. So in the neuroscience, I think at the turn of this century, there are two things that changed. There was a recognition that we are situated. We are situated in many senses. Our brains are embodied. Our brains and our bodies are situated in a particular environment, and you get into these arguments of inactivism, the importance of being an entity in a world, and how you couple two, or probably more accurately, how one measures or observes and samples the world, but specifically addressing the question that if you're a sense-making machine of this constructive kind, then you have to make sense of some data, but you are in charge of gathering that data. So we now get this wonderful circular causality, that you are making sense of data that you are actively soliciting from the world by querying the world, should it be there, through your sensory organs. So that inactivist or pragmatic turn in the 21st century accompanied a return to, or a realization that Helmholtzian-like ideas were probably on the right track.
Yeah.
And then we get the predictive processing, sort of promoted very much by people like Andy Kark in philosophy. And nowadays, I don't think many people would argue with the observation that 90% of cognitive neuroscience certainly is now pursued under the rubric or with a commitment to a predictive coding, predictive processing flavor or understanding of how we work, which is increasingly now accountable to this inactivist, the actions, what motivates our behavior, what are intentions, what is agency, all speaking to the fact it's not just about sense making in the spirit of unconscious inference, but very much depends upon the way that we actively sample the world. And just to bring that to closure, that was I think Helmholtz's move. So I've been told I'm a transcendental idealist. I have no idea what that means, and no one will tell me. Perhaps you will.
I'll try if I can. That's
So I presume that was Kant's position, but I think what Helmholtz did was to take that and say, yes, fine, but we also have to think about an engagement and an action upon the world. So many of sort of Helmholtz's contribution, considering the facts of perception, were actually about active vision and active sensing. One could subsume that under active inference nowadays, one application of the free energy principle. So I think that raises interesting questions, because if you are, and I'm going to ask you to define it in a second, a transcendental idealist, and you do not permit the existence of some metaphysics, what is it you are sampling?
The notion of transcendental idealism comes from Kant, who would say there is a world out there. It's not that we live in sort of a illusion or whatever. There is a real world, which you would call the noumenal, the Ding an sich, I think it's in German. But then the only how it appears to us is phenomenal. It's how we perceive it, the phenomenon. And that bridge is somehow unbridgeable for us. It's impossible to know the noumenon directly. And so we have to do with the phenomena. And me personally, I'm curious to hear your thoughts here. It brings me back to sort of the first thing Descartes said, that I know, therefore I am. You could say I feel, therefore I am, or I perceive a world, therefore I am. And stay with that. And that next category I want to introduce, the res extensa, which is a new metaphysical category, something that sits there independent of me thinking, me feeling, me sensing, is a philosophical leap that under sort of analytic idealism, you'd say you are not justified to make that leap, or you cannot make that leap. And then it says, why not stay as long as possible with that first assumption that the only thing I know is the world as it appears to me, and then try to best guess of what it truly is. And if you can do that without introducing a new category, so if you can say perhaps the world itself consists of mental states, or there's a mind of the universe, and it somehow splits off, it dissociates, and in your theory that would be, it forms Markov blankets, which are not something real, so to speak. It's a statistical object, right? It's a mathematical object, a doing of nature. So but now we're deep in philosophy, and I'm talking a lot here, but I'm very curious what your thoughts are here, because I see a very interesting overlap between your thinking, and I know you're not a philosopher, and agreed sort of, you told me I'm not a philosopher, but it's just sharing my view, and happy to hear what you think.
Well, that was very useful. I learned a little bit more about transcendental idealism and some other good words. And you said a lot of very fundamentally important things there. So my mind is racing, trying to sort of pick up on some of the key points. Well, let's go to Descartes. I think, therefore I am. I would put it another way nowadays. I am, therefore I think. So thinking, read as inference or sense-making, possibly decision-making, would be, I think, a natural consequence of just being. So as soon as you identify something, say the self, as existing, that puts a bit of pressure on disambiguating self from non-self. So immediately we have a partition. So I think the sort of the the distinction between the inside and the outside, or the was it the noumenal and the phenomenal?
Yeah.
I think that's actually you have to have that, because if you don't have a physics of an inherently relational sort. And in the absence of that, I don't think there would be a physics. And I'm now reading physics as observation. So physics just is measurement, making an inference, finding the right story that explains some measurement, some observation, some technical sensorium, if you like. So if all physics is measurement, then that, I think, introduces a fundamental distinction between the observed and the observer, the self and the non-self. So I think the deep question then is, how do we relate the self, the observer, to the observed, and vice versa? What is the relationship between the noumenal and the phenomenal? That is the issue at hand.
Absolutely. Because, it's a nice bridge maybe to your free energy principle. If I were to mirror the world as it is, so let's say it wasn't a measurement that gives me an outcome, but I can truly see it as it is, I would have to mirror all information, which would be like thermodynamically an unbounded entropy, right? Or what would happen? And because that's the starting point, that we cannot do that, right? So we have to sort of reduce free energy.
Yes. I mean, you could even apply one of Dennett's strange inversions here. If you were coupled directly to the world, and the world was directly coupled to you, there would be no way of distinguishing or disambiguating you from the world. So you wouldn't exist. You'd succumb to the principle of unitarity. There wouldn't be a you. There wouldn't be a self. So, in a sense, that's what I was trying to imply by the importance, the notion of some thing, some self, that is differentiable from the universe, should it exist, in which it is immersed. You don't have to induce or appeal to something outside the self, and then you would recourse to 20th century physics in terms of closed systems. So a closed system is just something that is closed. You don't have to worry. There is nothing beyond the system at hand, and from that you would then derive all the things like the free energy principle, but applied to systems that have an equilibrium solution. And you'll get the kind of physics and the kind of statistical mechanics that you did at school. Because that's not the name of the game in the 21st century. The name of the game in the 21st century is to talk about things that are not closed. They are open. They are open to something, but they are not something else. So they are distinguished by a boundary. In my world, that would be a Markov blanket. So now we're dealing with the physics of open systems. Technically, we're talking about self-organization to non-equilibrium steady states, suitably defined. It is likely that we will never actually attain these, but over a short period of time, there will be characteristic states that the self, or the thing in question, attains, in the sense that it is recognizable as that kind of thing by revisiting states that it was once in. So immediately you now have a mathematical image of a particular construct that defines existence, and this is a construct that you will find underneath all of physics. So I think one useful way of just thinking about the natural sciences in terms of the different kinds of physics that you might use to tell your stories at different scales of observation. So on the one hand, we have the physics of the very small, and this would be quantum mechanics. Then we have the physics of lots of very small things, and this will be statistical mechanics. And if we just drill down on one thing in an ensemble of neighbors, then that would be stochastic mechanics. And then we move up a scale, in fact, many scales, to very big things. And then we get classical mechanics that would also include general relativity, for example. So what's unique about all of these things? One thing is that they can all be derived from a simple description of any universe in terms of a random dynamical system. So the random part infers or implies that you have to deal with probability distributions, so they can all be articulated in terms of density, probability density dynamics. And one example of that, of course, is quantum mechanics, where you effectively take the square root of the probability of something being in a particular state, and that's your probability amplitude, and you can either take path integral or other approaches to derive Schrodinger's wave equations and all of quantum electrodynamics, for example. Or you can look at the probability distributions of ensembles, and then you get statistical mechanics. What happens when things get very, very big, though? Well, the randomness is averaged away. So it looks as if it's much less stochastic, and you could, and the kind of dynamics that you get now becomes much more predictable and deterministic, and ultimately you'll get Lagrangian mechanics and classical mechanics that include the behavior of all, say, massive bodies, where you can talk about mass. But the kind of matter, just coming back to your interesting dismissal of matter earlier on, which I loved, the kind of the mass that you find in Lagrangian mechanics has got nothing to do with the mass in quantum mechanics. These are completely different stories. And I think, but one thing which unites them is that they can all be written down as evolutions of probability distributions. So what's missing from all of these physics? Well, they don't consider one thing, one system in relation to another system, with the exception now of things like relational quantum mechanics, for example. What happens when you make that distinction? Well, first of all, you have to put in place a definition of how you would separate the observer from the observed, for example. Yep. And just using that language tells you immediately now we need a mechanics, we need a physics of observation. You could glorify that and say a physics of sentience. And that's the role of the Markov blanket. Yeah. And then what comes out of that is another kind of mechanics, a fourth mechanics, which inherits from exactly the same maths as quantum mechanics, statistical mechanics and classical mechanics. There's no magic here. It's exactly the same commitments, exactly the same first principles underneath it. But now it's a mechanics of something in relation to something else. And that now you can interpret in terms of this Bayesian mechanics as inference, as measurement, as sense-making, as unconscious inference, if you want to go right back to Helmholtz. You don't have to, but you can certainly tell quite a tight, rigorous story and then apply that story to understanding things, things at different scales, from sort of protozoa through to people, through to populations. The point here being that in separating the observer from the observed and writing down the physics of the observer without imagining some magical observer, writing down the relationship of the physics of the observer to the observed, you now have a mechanics of systems that are engaged and open and in reciprocal interaction with their world. And now you can talk about a distinction between the phenomenal and the noumenal, because you've now got a mechanics of physics that makes that distinction.
The essence I'm very much getting, and we see this sort of what they call sort of we've interviewed Marcus Müller, a physicist who's very much working on this, how to model the observer in observerhood, ideas like that. And then it's really about what will I see next? That's the question, and how to predict that. And you cannot do that. You don't know all the previous states. So it has to do with a Bayesian update of your beliefs, but then sort of rendered quantum mechanically. But that's still a bit abstract. I was thinking if we would bring this back to what people know, let's say sort of one of the boundaries our universe drew was first life, the first cell, right? It's a boundary. It's, for the first time, it's an inside and outside. From the soup of the chemical soup, we now have sort of a very dense soup with just all the right sort of proteins in place with a boundary that can start working. that is a physical boundary which we can measure from our perspective, but it's also but please correct me if I'm wrong. Your theory, the free energy principle, is then about the mathematics of that process, right? It's about the mechanism, the mathematical mechanism of what's happening there, that a bacterium has to form an image of the world to move away from acid towards oxygen or sugar or whatever. It has to do that. And so your theory is not about what the bacterium is or what sort of protein, but it's about the mechanism, the mathematics of that, right? And then very first principles, it's about physics of that.
Yes.
So is it a physics of life then? I'm hearing myself talking about it. Is it a physics of life in a sense?
Yes, I think so. Yes,
yeah.
That's actually the title of a journal where I enjoy publishing most of my interesting work. Yeah, I can't resist this picking up on this notion of the primordial soup, and coming back to your observation before. What would it be like if we were in direct contact with the world? If we could see everything, we would be part of that soup. So, the very emergence of something in a soup, the very emergence of some pattern in the spirit of sort of Mike Levin's work, or a pattern, a Turing pattern in the spirit of Turing and his relationship with sort of early cyberneticists. The very emergence of the boundary is definitional of the thing. So what the free energy principle says, well, look, if there is something, then it has to possess a boundary. What is the nature of that boundary? Well, the nature of that boundary speaks exactly to your lovely description of transcendental idealism. It is that you cannot be in direct contact with the outside, otherwise you will be part of the soup. So how on earth then do you conceive of a boundary that is intimately porous and glues you to the soup, of which you are a part, but also at the same time distinct? And the trick is you effectively use, again, statistics or probability theory, information theory, whatever you want to call it, to define the minimal conditions that allow for a statistical separation, a veil, something that is shared between the observed and the observer, but is not the observed or the observer. And this can be read in many ways. We've mentioned Markov blankets as a statistical object due to Judea Pearl. People like Chris Fields, a friend of Mike Levin, would conceive of this from the point of view of quantum information theory as a holographic screen. I think the key thing is there has to exist some separation between the observer and the observed. And if that exists, and both sides, including the boundary or the Markov blanket, exist over time, then they have an attracting set. Technically, it's called a pullback attractor. The very existence of the boundary, the separation, the distinction between the observed and the observer, means that the dynamics have to follow certain rules. And they're not magical rules; they're really, really simple rules, which you profess to being an expert in many things, but not a physicist. But you will have done at some point the principle of least action, Hamilton's principle of least. So the free energy principle is a principle of least action, but it is applied under the special constraint that you can separate the observer from the observed, or the thing from everything else, or the self from others, or the non-self. And what emerges from the principle of least action applied in this special context of the separation is the space mechanics, which now licenses you to put a teleology or a story on this dynamics, this mechanics, technically a sort of, it is exactly a gradient flow on the self-information, which I think is very sweet because we've got self back there again. And the self-information is the thing that on average is called the entropy. So we're always trying to, it'll look as if the dynamics of both the inside and the outside and the separating states, the blanket states, the boundary states, they look as if they're always trying to minimize self-information. So what does that mean? Well, it means something absolutely trivial, almost tautological. It just means that it'll look as if they're flowing towards the states that they most likely occupy. So this is exactly the same tautology that you'll find in evolutionary thinking. It's just a description of how the dynamics of anything have to behave if they have this attracting set. They will always be attracted to their characteristic states. So it'll look as if their dynamics are such that they are flowing up probability gradients, where the probability gradients just describe the most likely states of affairs, or the most likely states that you'd find this kind of thing, this natural kind of thing. And that's all it is. That's the principle of least action that is a free energy principle. It's tautological.
Is this all a difficult but accurate, because it's a first principle theory and it's new, so it is hard to understand exactly for that reason. But is this all to say that I'm just see how we can bring it back to a bit more understandable sort of notions for our audience? But say we go back to the bacterium that wants to sort of navigate the world, and so it has to have a boundary, it has to model that world, and it wants I thought, please correct me if I'm wrong. I was thinking, because the free energy principle, what puzzled me with the term is sort of just the word free energy, right? Because I think you hear this a lot, right? This question, why is it called free energy? And I'll give you sort of in thinking about it, what I thought. In a sort of Shannon information sense, information means sort of lots of information is also high entropy. Like a noisy picture is hard, with lots of details, is hard to compress, right, for our camera. So we'll see larger file sizes, so it's more information, it's more energy. And whereas thermodynamically, free energy, if I can get free energy as a system, that sounds like a good thing. Who wouldn't want free energy, right? That's what people will understand. So that's when you then say you reduce, organisms want to reduce free energy, you're a bit puzzled. But in the Shannon sense, this is what I'm thinking, you don't want the world to confront you with surprises that are a lot of information to take in and model. If something totally weird happens in this room, I have to remodel, and will sort of just cost me a lot of energy. And I want you to be just sitting there and having this conversation and sort of predict what your answer will be to this question I just posed to you. Is that a way, sort of this does that help, sort of that Shannon sort of interpretation of information, energy, and how we want to reduce it?
Yes.
Okay.
I'm just admiring your masterful attempt to bring it back down to things that are... Yes, I apologize. I got carried away with the...
I think there are people in our audience who really appreciate it, but also people who just a bit more like me trying to sort of indeed grasp it. But
right.
Yeah.
So perhaps then, just to rehearse what you've just said and to sort of join the dots. So this self-information just is surprise. And the free energy is just a what's called a bound approximation to the surprise. Yeah. So all of this, when we talk about the path of least action, we're just talking about that things that persist in the sense that they maintain their self-organization and particularly their interface with the world or their boundary, look as if they are constantly trying to avoid surprises. That's all they're doing.
Yeah.
And it can be no other way. And the surprise here has many different sort of mathematical interpretations.
Because that's very important, I think, just because we said earlier, if you would let all the surprise in, entropy would go up and you would go back to soup.
Exactly.
Check, yeah.
Exactly. Yeah. So that's one really important observation. So we're just talking about, what a physiologist would know as homeostasis. We're just, if we exist and we are defined by our boundaries and our blankets, and just a nod to the fact that there are blankets and blankets and blankets. So it's not just one blanket. It's delicately structured blankets within blankets within blankets. But if they persist in time, then that is just a statement that we have not dissolved into the soup. Technically, we have resisted the dissipation, the random fluctuations in this random dynamical system that is the universe from which all the other mechanics inherit. And that just is a statement from a point of view of physiology of homeostasis, that, I keep things like my temperature, many embodied aspects of my being within viable bounds. Cyberneticists might have referred to this as essential variables.
Yeah.
That's exactly the same as saying that I possess these characteristic states that it looks as if I'm attracted to my homeostatic set points. It looks as if also I am trying to avoid surprising, traumatic, aversive, unfamiliar situations. It also, this is the interesting twist here, mathematically, if you just think about what is surprise, well, it's just the implausibility of being in a particular state. So what we're saying is things that have characteristic states that they are most likely to be found in will look as if they're avoiding implausible states that they're unlikely to be found in. So this is the tautology I was trying to get at. So one way of saying that something exists in terms of possessing some characteristic states or an attracting set that inherits from the dynamics that the Bayesian mechanics affords, can also be described as avoiding surprises. So this is one of the sort of teleologies and the stories you can put on this really fundamental aspect of self-organization. But the nice twist, which brings us to the philosophy part of it, is that the implausibility, the negative implausibility, is just the logarithm or some sort of monotonic function of the probability that I will receive this impression from my world, given me as a model of that world, given the kind of thing that I am. In statistics, that's known as Bayesian model evidence. It's simply, this is a good model because under this model, if I generated some data, the probability that the data I actually receive is very, very high. It explains, it fits this data. So that's called model evidence. Yeah. So it looks as if I avoid surprises by minimizing my self-information from an information theoretic point of view, I can equally well say, well, this is just the same as gathering evidence for my model of the world. So I can tell a story about self-evidencing, which of course is what Jacob Howe tells. So all of these different perspectives are on exactly the same physical fundament. Yeah. And that at the end of the day, that physical fundament is almost tautological. I think I like that about your theory. And then of course, what I also understood, and that's why it seems so complex, but in thinking about it, I could make sense, not of the all the mathematics, but the fact that you're optimizing for something you cannot know. So that you have that difficulty, right? Because you don't know what surprise is. So you also don't know what that sort of level of surprise. Is there an optimal level of surprise? You just don't want any of it all? I've seen sort of, if you draw the log, you're optimizing for something you cannot know. So you want a sort of an algorithm that helps you out, right? Yes.
And this relates back to Feynman. I all find this so fascinating. I just don't fully understand it. But it is relate your back work to the physicist Feynman, right?
Yes,
and his sort of the path, electron stake, and what he discovered.
Absolutely.
But only if you can keep it simple for our audience. I don't want to sort of get us too deep into the rabbit hole, but
there's so many wonderful rabbit holes here. Let me just try and cover a few of them because because it would be a great shame just to not celebrate some of your observations. First of all, the free energy of the free energy principle is exactly due to Feynman. It is exactly the same free energy that he devised to solve certain path integral problems in quantum electrodynamics. And the way I phrase it like that is that we can think of a physics of life as really the solution to a path through different states of being. And that solution is a least action or maximum efficiency, minimum surprise, minimum prediction error, maximum model evidence. They're all different ways of describing exactly the same thing. So it is all down to Feynman. Certainly the pathological formulation of the free energy principle. What were the other things? So many things.
So you're optimized for something you cannot know.
Optimization. That's a really crucial thing. The gift of Feynman So I just want to make the fundamental point.
Yeah.
Existence, it does not need to be read as optimization. But if you just look at economics, machine learning, even statistics, it's all cast as optimizing something. What? And that's a really deep question. And certainly if you're in machine learning, this is the value function selection problem. No one knows. Or some people think they know, and then they prescribe their reward. This is a behaviorist, sort of the legacy of behaviorism that you see in current deep reinforcement learning. But it's all a nonsense. As you say, no one knows, because optimization, you have to think, where does optimization get into the game? Why do you won't find optimization in quantum mechanics. You don't find it in statistical mechanics. What's statistical mechanics optimizing? What's quantum mechanics optimizing? So the reason I sort of ask that question is that you can convert a description of self-organization into something that looks like an optimization problem. And that's exactly what Feynman did. So what he wanted to do was to work out the probability distribution to describe the distribution of paths that small particles could take in his world. But couldn't do it. It's intractable. It's an impossible problem. So what he did was induce what's called a variational bound, which is the variational free energy, which can be computed, which approximates this solution. And in so doing, was able, and a bound simply means that something is always bigger than something else. So by minimizing the bound, he could then evaluate what he couldn't actually calculate, which was underneath that bound, just by minimizing it. So he turned an impossible marginalization or integration problem, we don't need to know what that is, it's just not an optimization problem, into an optimization problem by inducing the free energy, which tells you that the universal objective function is the variational free energy. So then it's a question of working out, well, what is the variational free energy? Well, it's just an upper bound on the surprisal, or the surprise, which just means that...
So you cannot sort of know exactly where it is, but you try to minimize it, get as close as sort of... Yeah.
And of course, the way that you phrased one of your earlier questions about, to be surprised, I have to know what I expected. To know what I expected means I have to have a model that can predict something.
Yeah.
So this almost writes a narrative where it is necessary to think about us as modelers of our world. And this now brings us right back to cybernetics, for example, which was, say 20 years after Helmholtz. And one, I think, well, there are two sort of laws that came from that era, which I think are very pertinent to this discussion. One is the good regulator theorem, and one is the law of requisite variety. So the good regulator theorem is just basically the notion that any agent, any observer immersed in a controlled environment has to be a model of that environment. And, nowadays we read that as a generative model that can generate predictions about the consequences of action. And the law of requisite variety is just effectively says there has to be a sufficient number or equal or number of degrees of freedom on the inside, say my brain, as there are things that I can act upon or control in the noumenal, in the outside. So these, I think, are useful concepts that sort of shake hands with cybernetic notions of being in a world in this sort of inactive and controllable sense.
Yeah. And I think the fact that we, a bit back to that philosophical notion that we sort of confuse sort of our phenomenological experience of the world with the world as it truly is because it's so super accurate, but in a sort of healthy, but sort of like in many brains do their job so good that we're not very often confronted with anomalies. But what fascinated me in how you came up with the free energy principle is that you started out as a psychiatrist at the bed of patients who had sort of schizophrenia, and that sort of triggered your fascination, right? If I'm not mistaken. So I'm just curious, maybe you have a story for us of one of these patients, because there we would see in schizophrenia, you see like world models that are not accurate, but people keep updating them and somehow reinforcing false models of the world. Is that a way to put it? But maybe just nice for you to share with us maybe a story of that period in your life and what fascinated you about it.
Yeah, well, false models, I think, is a really important concept there. But to answer your question,
It's a bit normative language there. I'd say not accurate. I don't. But anyhow,
I think it's very accurate, and it's certainly a sort of a theme in computational psychiatry. So just to preempt any stories that I might have.
Before we continue with the conversation, I want to tell you about the sponsor of this video, Consensus, an AI-powered science search engine that lets you search over 220 million peer-reviewed papers with direct links to the studies. For instance, if I ask, is the consensus in neuroscience that we do not see reality as it is? In its pro mode, Consensus immediately surveys hundreds of studies and presents me with a consensus meter, where you can see that indeed the majority in neuroscience points to the fact that we do not perceive reality as it is. In preparing podcasts like these, Consensus is a great tool to get fast insight in someone's work. For instance, when researching Karl Friston, I get a great overview of all his scientific publications, for instance this landmark paper on the free energy principle. And this makes Consensus stand out in comparison to other LLMs. It is a scientifically rigorous research assistant unclouded by social media, blog posts, or other pseudo-scientific sources. Consensus can be used for free, but if you want access to the pro features, you can click on the link in our description to get a 1-week free trial and a 30% discount on the first year thereafter. I do want to make an ethics statement. The Essentia Foundation is editorially completely independent, and we only accept sponsorships that align with our mission and scientific standards. Now back to the conversation.
If just being in the world is effectively to be an observer in the world, gathering evidence for your model of the world by minimizing your surprise, and if you can describe this process as inference, then that means any failures to interact with the world or to be in the world, and in particular a pro-social world that involves other things like me, other people, can be read as false inference. So this false modeling or false inference notion, I think, is absolutely central to understanding suffering, to understanding, let me give you an example. At school, we are taught that there are two kinds of false inference. There's type 1 errors, basically inferring something is there when it is not. Mm-hmm. And this would be a perfectly apt description of hallucinations and delusions. But we can also make type 2 errors, inferring something is not there when it is. And of course, this is the kind of false inference that you'd find in neglect syndromes, dissociative syndromes. In the old days, we would call hysterical syndromes. So nearly every psychiatric and a good swathe of neurological disorders can be understood in terms of false inference. And with a little bit of poetic license, I think that is exactly false modeling. So, I think you could talk about aberrant inference and and nuances on that, but I think false inference speaks exactly to the sort of the kinds of errors you would make when you're doing statistical inference with t-tests and the like. But the personal story, you're absolutely right that I have a sort of bilateral career. So I always wanted to be a mathematical psychologist, but that sort of changed into being a theoretical neurobiologist and a computational scientist. So computational neuroscience wasn't invented when I was a youngster, but I certainly chose a career that enabled me to pursue the most interesting thing in the universe, which of course is me and you, our brains, and ended up as a psychiatrist, a very formative part of my life, specifically spending a year or so in a therapeutic community, sort of living on site in a community with lots of chronic patients who had schizophrenia largely. A time of my career where, well, I won't tell any stories. But I don't think that would be in terms of
respect for patients.
In terms of respect,
of course.
Yes.
I understand that.
But there were some wonderful occasions, and awful occasions, in terms of containing, some of the psychotic episodes and acting out, but lots of lovely occasions. The ones that I best remember was a commitment to group therapy. So you don't normally do group therapy with people with schizophrenia, but we did. Nearly every day we'd have these enormous groups, and in those days you were allowed to smoke. And that was
that helps.
that certainly helped. Well, also it was a really interesting mechanism for communication within the group. So who would light up? Who would offer somebody else a light or offer somebody else a cigarette? So it was always interpreted as a form of sort of oral nourishment, and some mischievous interpreters sort of regarded as oral masturbation at some point. So smoking was quite a central theme in those days. But I do remember, some of the beautiful things that you can get from false inference, and I'm using false inference here in the sense that we are all subject to false inference, and we can talk about illusions later on, which is necessarily the case, because inference is never truth-pointing. It's only inference to the best explanation. So if you do believe there is some metaphysical noumenal, then everything is false. It can't be any other way. And there are good mathematical reasons why that has to be the case, in the sense that if you consider now physics and measurement and being and thinking in the sense of Descartes, I think, therefore I am. And if we come back to that, I am, therefore I think. If I exist, then I can be described as inferring to the best explanation. So the best explanation is not the truth. The best explanation is mathematically, you mentioned entropy before. So the entropy that is maximized in minimizing the free energy is not the entropy of our interactions with the world. It's the entropies of our measurement or our belief, our illusions, our explanations, our stories. And we're always trying to maximize that to keep our options open. And you can find this in things like James's maximum entropy principle. You can also find it in things like Occam's principle. If you'll see this everywhere. You also find it in terms of compression arguments, complexity. So you're always trying to find, in the words of Einstein, an explanation such that you keep things as simple as possible, but no simpler. So you're always trying to minimize the complexity of your accurate story, illusion, false inference, that best explains this sensory input. So
we're optimizing that balance between accuracy and complexity. I like that sort of that. I saw, that's it, right? But strange things can happen there, right? I mean, what fascinated me, talking about what you say, how schizophrenic patients sort of have false inferences. I read somewhere in your, I don't know if you read about it, but I read that there are instances where they make the right inference and healthy, normal brains make the wrong one. That fascinated me. For instance, isn't that with the hollow mask example, where we sort of just see it? We have a false model of the world.
Yes.
It's sort of an outward-facing face, but it's sort of curved inward. And you keep seeing it wrong. We can share the image on our screen, and I'll put a link down. This is so fascinating to me, because I read that some people with schizophrenia don't have that. They see it right.
Yes.
What's happening there?
Yeah, that's a brilliant observation. Yeah. So, and it speaks to a lot of things that we've already mentioned. So the hollow mask illusion, I think, is a wonderful illustration of our susceptibility to false inference, finding the simplest explanation for this pattern of visual input. And of course, the simplest explanation is not that the face is inverted, it is a face. And we cannot cognitively penetrate that. You can't unsee this false inference, this illusory inference, this sense-making, simply because it's the simplest explanation for this particular pattern. Because you've never conceived of, in the sense of Helmholtz, an inverted hollow face. You've never, you don't have it on the inside to interpret it. And that's another way of saying that the simplest explanation for what you're seeing is actually a face that is illuminated in the normal way that you have grown up in terms of experiencing things. So illusions on that view are wonderful tools for psychophysicists and experimentalists to probe our prior beliefs, our biases that belie or reveal the prior beliefs that we bring to the table. Now, I use prior beliefs here in the sort of Bayesian setting, just as sort of technically, you can carve up your generative model into your sort of likelihood part. What's the probability that these data would be observed if this state of affairs was true? And then I have a prior belief about this state of affairs. And of course, 99% of being in the world and learning and experience is to build the right kinds of priors that provide the simplest explanation for what's going on. So another instance, there is no truth pointing. It's always inference to the best explanation, and that's, I repeat, beautifully illustrated by illusions. But here's the key point. You're absolutely right. There are certain people who are resistant to these illusions, as if they can suspend their prior beliefs and become more accurate in terms of reporting the actual causes that the experimenter knows is true of their sensory impressions. So, and indeed people with schizophrenia are notoriously resistant to these illusory phenomena. So what does that tell you? Well, it tells you that they're putting more balance on the accuracy than the complexity. From the point of view of this sort of decomposing the generative model into a prior and a likelihood, it tells you that they're affording too much, in my world this would be precision or confidence or credence, to the likelihood relative to the prior. And that sort of suggests that the primary etiology, the primary cause of this sort of false inference is due not to what you're seeing on the sense-making, but the precision or the credence or the confidence ascribed to sensory evidence relative to your prior beliefs. And, perhaps the poster child psychiatric condition that best exemplifies this would be severe autism. Imagine what it would be like that you could never ignore anything, that you're always compelled to assign a certain salience, a credence, a precision to all your sensory sensations. You'd be glued to the sensorium. You'd be fascinated with the details. You would never build a sort of coherent narrative where you could have these illusory abstractions, simpler explanations that you and I bring to the table without being aware of it. And you're going to avoid anything you can't explain because you have to explain everything. So you're going to try and make the world as predictable as possible. You're going to avoid too much stimulation. You're going to engage in self-stimulation called self-stimming to make the world as predictable as possible, simply because you have to explain everything
accurately.
Yeah, because you can't ignore it. You and I.
And you cannot accurately explain complexity. If you completely accurately want to explain complexity, then you have a big problem sort of in what we're relating to, sort of then your free energy is like through the roof, right? So therefore you avoid certain complexities.
Yes.
Yeah. And we always have to navigate complexity with a certain threshold of accuracy, or we have to sort of be, and then that's the human condition under the free energy principle.
Yes, absolutely. And it all rests upon the relative, I repeat, mathematically it's precision or negative entropy. But you can think of it as sort of, the credibility or the confidence. Perhaps it's to make this a bit concrete and more accessible. So Andy Clark tells a very good story. One sort of formalism of this sense-making and illusion building, but the right kind of the best illusions, inference to the best illusion, is predictive coding. Yeah. And in predictive coding, one reads the self-information, surprisal, the negative model evidence as a prediction error. So you can just think of the brain generating predictions of what it would sense if it had got the right story at hand, if it had arrived at the best guess that completely, or to a certain extent, explains accurately this sensory input. Now, how would you score the surprise that you want to minimize? Well, you just subtract the predictions from the sensations. That is just the prediction error. And then you use the prediction error to adjust your explanation for the world until the prediction error is eliminated. So if I can predict in the sense, or not eliminate, but certainly reduce, so that you can't reduce it any further. So you can also describe this self-organization, this self-evidencing under the free energy, the Bayesian mechanics, as basically minimizing prediction error. But there's a problem here. That prediction error could come from many, many different sources. It could be a sort of visual prediction error. It could be an auditory prediction error. It could be from my own. It could be from my body. And furthermore, there are prediction errors and prediction errors and prediction errors in a sort of deep generative model with this hierarchical form. So there's a problem here that I have to weight the prediction errors in order to give them a selective advantage in updating my beliefs. Technically Bayesian belief updating.
Yeah.
So the way that Andy Clark explains this is that, if I get some information, some sensory information, this is like news. But what is the newsworthy part?
Yeah.
Well, it's that which I didn't predict. It is the prediction error which is newsworthy.
Yeah.
So we don't watch the 10 o'clock news on the television or on our mobile device to hear things that we could predict.
Yeah.
We basically seek out the prediction errors to resolve and update our beliefs. So now you have to choose which of these newsworthy bits of information, namely the prediction errors that score the surprise that we're trying to minimize, according to how precise you think they are. So basically, you're turning the volume up on certain sources of information. You're attending, say, to your visual modality, or you're choosing CBN as your news source in America, as opposed to Fox or your auditory modality. So you have to choose what to attend to effectively. So in psychology, this would be attention. Mathematically, it's this assigning the right precision.
Yeah.
Physiologically, it's mediated by exactly those brain chemicals, neurotransmitters, that we change when we give psychiatric drugs, for example, or indeed take psychedelics. So there's a lovely convergence mechanistically from the sort of the psychology, the Bayesian mechanics, and the neuropharmacology, in terms of all focusing on who do we listen to. So a simple example of this would be, if I go into a dark room, say a hotel room that I've never been in before, and the lights don't work, then I know that the visual prediction errors are not going to convey very much information. They're going to be ambiguous and imprecise. So I'm going to downweight those because they're not newsworthy. And I'm going to, in a complementary way, increase the precision or attention afforded palpation, somatosensory input. Yeah. Or indeed, I might listen very carefully if I can hear a clock or I can hear a radio.
What there's so much here. It's still, I think, but we can also, we will share links and help sort of people understand it, because I think it's so fascinating to understand all of this. One idea, just this, we sometimes, we are storytellers and we're making this story, and it also has to do with meaning making. So for instance, I was just hearing you talk, I was thinking, is the free energy principle in a sense also a mathematics of conspiracy theories? And hereby, just what I mean is that people have false beliefs about a complex world, and we don't like complexity. We don't like sort of the people who are sort of doing stuff in the world. We don't like to be sort of people who intended it to be good, and that there is not a single actor on which we can plot sort of all the evil in the world, but we're somehow part of it all. That's tremendously complex to just understand our world and geopolitics. What we do like, we want to have an accurate explanation somehow of what's happening. from a meaning-making perspective, and then you end up, of course, with conspiracy ideas that don't handle the complexity but are accurate in your world because you have now a story. So that's an idea I had when hearing you talk. It's the same mechanism in a sense, right?
Yeah, absolutely.
Yeah.
But that thought, I think, sort of takes us into a really interesting world, because at the moment we've just been talking about the observer and the observed.
Yeah.
But when the observed is herself an observer, we now enter a really interesting. What is the mechanics of exchange between things that are sufficiently complicated and sufficiently evolved and sufficiently big, literally in terms of their scale, that they can both be regarded as making inferences or self-evidencing about each other. So now my world is now constituted by things like me. Yeah. And that affords this really interesting opportunity. So if I'm in the game of self-evidencing, gathering evidence, or I should say, from the point of view of the free energy principle, it looks as if. So, this is a story you can tell about the basic mechanics. So it looks as if I'm in the game of gathering evidence from my model of my lived world, or my sensed world. Then I now am in the game of inference, the best explanation about you. What causes you, what best explains. So it's the simplest but accurate explanation of everything that you generate in terms of communication, in terms of all the cues that you offer me, auditory and visual, or on social media. One way of doing that is to make the simplifying assumption that you are like me. Because if you're like me, and I can infer that you're the same natural kind as me, then I can explain your behavior in terms of the intentions that I had that would explain the same behavior in me. So now I've got sort of a ready-baked theory of mind, but it only works if you're like me. So all I have to do is to rifle around, identify things like me that share the same generative model, the same common ground, the same narrative, the same worldview, and then engage with those people, because that renders the world much more predictable and surprise minimizing. And if we all do it together, the argument is exactly symmetrical. So now we can minimize our joint free energy together just by converging on the same world model, the same conspiracy theory, the same theology, the same ideology, the same language. If we all converge upon the same one, that becomes now the joint mechanism, or an expression of basic mechanics, in this special situation that you've got lots of observers all observing each other. And
fascinating. But this makes sort of your theory. So we can draw the Markov blanket on sort of a whole group in society that has a way of group think that you can mathematically draw a boundary around.
Yes,
that group.
And I personally haven't, but I have young colleagues who have absolutely done that. But notice what you've just done though. If that boundary is impervious, you've now created a closed system.
Yeah.
My apologies.
No problem.
You've created a closed system. So we're now back to 20th century physics, and everything will converge on an equilibrium, which will be sort of the echo chamber, and nothing will change.
Yeah.
But of course, that if it's a Markov blanket, it's porous. So now you get this sort of interesting situation where there's a tendency of the in-group within this sort of meta-Markov blanket that surrounds this particular group, where there's a tendency for everybody to converge upon the same narrative, the same worldview, the same generative model. And yet they are trying to infer, or look as if they're trying to infer as a group, the outgroup, or the collections of outgroups in which, with which they're. So there's necessarily a scale invariance or a scale freeness. There's this kind of group formation, because if there wasn't, you would actually have a closed system that was isolated from the rest of the universe, and that can't happen. We're always in a particular context, so there are going to be groups of groups of groups of groups at increasing scales, where within each group, everything is trying to, if you like, reassure itself that they got the right world view, but at the same time trying to accommodate the larger context in which they're operating. So some really interesting. I'm not sure there are any analytic solutions. I don't mean mathematical analytic solutions, as opposed to philosophical. But you can certainly sort of search for do numerical studies and just look at the kind of patterns of group formation that emerge under sometimes described as epistemic communities. So a community would be an ensemble of observers that are all trying to minimize their surprise through this epistemic foraging, acting in a way to minimize prediction errors in the future by seeking information, but doing so in a way that they're imbuing certain people with an epistemic trust because just because those people are like them, or those institutions are like them. And then you get the emergence of interesting dynamics. I'm not sure whether you want to use this piece, but
No, please continue. Yeah.
One sort of particular solution which always catches my eye is when you simulate this kind of active inference in an ensemble or population context, is that one steady state or non-equilibrium steady state solution, which can be likened to an evolutionary steady state or stable state, is a 50-50 split. And certainly in the past decade of me politics watching, you see this time and time again, that the only stable solution, by which I mean if one group is too small, it will be absorbed into the other group because everybody's trying to seek the in-group. And if everybody's doing that, there'll just be one in-group. So this 50-50 split is the only stable solution, where you've got both the reassurance of being in your in-group, but you've also got the epistemic allure, the sort of novelty, the sensation seeking by looking out there to the outgroup. You can laugh at, I won't mention, you can laugh at the others, or not laugh. So you see this time and time, remember Brexit in the UK?
Yeah.
It was exactly 51, 52, 48. Trump versus Biden. Independence debates, wherever you look, whether it's Montreal or whether it's Scotland, it's always 50-50, because that's the only stable solution in terms of the joint free energy minimizing process, where there is a Markov blanket between the blues and the reds, whatever they might mean.
So fascinating. One question I have is, I've been sort of trying to get my head around integrated information theory, which I like for the fact that, exactly as your theory, it's able to draw a boundary, to just not be sort of loosely saying this is conscious and to not have sort of just best guessing around consciousness, whereas IIT says, no, we can sort of have mathematically, when we calculate the phi of a system, we can see exactly, for instance, what neurons are involved with consciousness and which aren't, which I think is very good for science, because then you can make accurate predictions. So I like that. But under integrated information, also, as in your theory, it can scale up, so to say. If the phi is of a bigger system, then I would sort of cease, if we have an interconnection between our brains, as Christoph Koch explains this to me, right? And we keep on making connections to our neurons. There will be a moment when that sort of collective integrated information will be higher than the ones now sitting here, and we will become sort of a group mind, or that's what the theory points to or predicts. Under IIT, that also involves that I somehow cease to exist as a conscious unit. Whereas, I'm just curious, how is that in your theory? If the Markov blankets gets bigger, can there be Markov blankets within the Markov blankets, and are there selves within a bigger self?
Yes.
All right.
Well, let's dwell on integrated information theory.
Yeah, curious what your thoughts are on IIT.
Well, I should confess, so Giulio Tonelli was one of my best friends when I worked with Jerry Edelman in America at the inception of IIT and related ideas. And Christoph Koch is also a valued colleague. So
it's fantastic.
So I have a personal investment in sort of respecting IIT, and I think I can easily respect it from the point of view of a much simpler kind of maths. Well, possibly not simpler, but certainly from my point of view, more classical, understandable kind of maths, or a first principle account, which I would contrast with the axiomatic account of IIT. So although I've heard Julia say it is a principled approach, it's not. It's an axiomatic approach. It starts off with axiomatic assumptions and then builds from there.
Yeah.
Whereas a free energy principle is a first principle account. There are no assumptions. Everything is emergent from the starting point, which is just there exists a random dynamical system. But the endpoints of the analysis, I think, bear remarkable similarities.
Sorry to interrupt you, but when you say you don't have axioms, wouldn't your axiom be that that nature creates the first Markov blanket, or how to account for the fact that Markov blankets exist?
Well, how the free energy principle is not an explanation for why Markov blankets exist. The free energy principle is a description
What they do
of things that are defined in terms of Markov blankets. So this is.
But I would then say that's your axiom, that those things exist that have a Markov blanket. Isn't that then your axiom?
No, not really. No.
Okay.
I think the reason I hesitate to agree, which, I usually like to agree, but in this instance, no. I think there's a lot of heavy lifting to be done beyond the free energy principle, or perhaps within the free energy principle, to explain why it is the case that Markov blankets do emerge. So why did this single cell first emerge from the primordial soup?
Of course, we don't know. Biology cannot tell us.
Yeah, I mean, this is exactly the kind of sort of question that everybody's trying to answer, including people like Mike Levin from a biological perspective, through to people like Stephen Wolfram. This is an outstanding question, and I think that's a notion of the emergence of a Markov blanket within the primordial soup. And then the emergence of Markov blankets, where you get these multicellular organizations. That's an important concept, because you need that multicellular blankets of blankets to have these deep hierarchical structures in order to have the kind of sense making and the Bayesian mechanics that we were talking about previously. You can certainly apply the free energy principle to a single cell or a thermostat, but it's a little bit trivial. It becomes much more interesting when we talk about big things that have this sort of scale invariant structure with nested Markov blankets. And of course, we're talking about populations of interactions in other minds, which is the sort of highest level of this sort of interactive inference or intersubjectivity or measurements of others. So IIT does, so the free energy principle does not say it is the case that a Markov blanket will emerge from a primordial soup. What it says is, should something exist, it has to behave like this.
Okay. Yeah.
And you may ask, is that useful? Not in and of itself, because you could say natural selection, evolutionary theory, is a very powerful theory, but it doesn't tell you at all why I speak English or why you have two eyes. So in itself, the free energy principle doesn't really gets you as far as a law of least action in Newtonian mechanics. So you have to apply it. So the free energy principle only becomes useful when you apply it, and when you apply it, you get Bayesian mechanics, active inference, and everything we've been talking about.
Sort of that notion of selfhood, sort of being inside a Markov blanket, modeling the world, it can scale up to larger ensembles with those individual Markov blankets still existing. So we consist of trillions of cells. Those have Markov blankets, and there's a Markov blanket that is Hans. And they exist simultaneously, and I think that's interesting, and it's also in line with Michael Levin's work, who also sees these things as scaling, whereas IIT looks at the integration of all of that and then sees a single unit. So there, that you do differ from IIT.
I see, right? Okay, yeah, that's a good point. So the point of contact I was going to foreground was the information partitions that you need to define phi, and in a sense, it is not surprising that calculus is required in order to elaborate an information theoretic account of consciousness.
Yeah.
In the same way that the starting point in the free energy principle is the Markov blanket, a partition into observed versus unobserved. For me, though, where IIT ceases to become interesting is that there is no distinction between the observed and the observer. So the information that IIT talks about is not information about the thing on the other side of the blanket or the partition. It's just the information that a thermodynamicist or a brain imager would measure. It's the entropy or the thermodynamics of that partition in and of itself. Whereas the free energy principle, the information that you're talking about that is represented on the inside is about the outside. That is the essence of observation, is essence of measurement. So there are distinctions. In relation to your comment,
but this is a very interesting point. I'm trying to understand this. I think the key here is also to make clear for everyone watching that, correct me if I'm wrong, that the free energy principle is not a theory of consciousness per se, right? It's a theory of how agents or selves have to model the world. So to me, it's much more, it's about cognition and intelligence, because the phenomenal consciousness, what it is like to beiness of something, what it is like to be inside a Markov blanket, which is sort of the feeling, the qualia, how it's called, and integrated information is about that. Starts with phenomenal consciousness, and that's a different departure point, I'd say.
Yes.
So, but I'm curious to if you would agree when I say your theory is not a theory of consciousness, and then also, of course, how it does or does not relate to consciousness. Is it a theory that cannot say anything meaningful about consciousness that because it does not cover consciousness, or does it relate to phenomenal consciousness? I'm super curious what your position is here.
Right. You're absolutely right. The FEP, well, first of all, the FEP is not a theory, it's a principle.
Sorry. Yeah.
And that's technically important because in physics, a principle, you have to apply it. So you don't falsify it or marvel at it or shout at it. You just apply it or you don't. Whereas IIT is a theory, which may or may not be wrong, and it's it's a hypothesis. The free energy principle is not a hypothesis, it's just a mathematical tool that you would apply. And as such, it certainly is not a theory of consciousness. Is it a principle that could be applied to consciousness research? Possibly. And people try, and people are trying it. So interestingly, I'm currently engaged in the denouement, the last year of a Templeton funded adversarial research collaboration pitching active inference against IIT. So Giulio's the theory lead on the IIT, and I'm the theory lead on the active inference side. And in order to do that, because one has to be adversarial, I'm not sure that's the right way to do it, but that was our brief. So we had to pick something that sort of could be seen as an application of the free energy principle, namely active inference. That disambiguated it or made it distinct from, in an adversarial sense, IIT. And the thing that was eventually emerged was action. So it was possibly best summarized, actually, somewhat in relation to what I was trying to get across when talking about the difference between Helmholtz and Kant, that to see is to look. To hear is to listen. There is no passive inside-out registration, qualitative experience. The qualitative experience and the phenomenology rests in this application of the free energy principle which may, and the application may or may not be, a correct theory, then you have to be an agent. You have to be an agent that is actively soliciting this kind of information from the sensorium. And it doesn't have to be on the outside. You can do that on the inside through this attention-like mechanism we were talking about before. Remember, we were talking about assigning precision or a newsworthiness to certain sources of prediction errors. This is a very inactive capability, which not everything has. So a thermostat wouldn't have this. You could argue that to a certain extent, even single-celled organisms wouldn't have, although you could argue that catalytic interactions and enzymes do this in a certain way. But, in terms of consciousness research of the kind that we're talking about, qualitative experience, then what that suggests is that you have to have a natural kind with a deep generative model that can act on itself. So deep layers or levels of a generative model can make sense of the computations of layers that intervene between the deepest and the sensory level or the sensorium. What would that look like? Well, it would just look like exactly what we were saying before in terms of turning the knobs by assigning greater or lesser precision to various belief updating dynamics, various sense-making procedures, say like predictive coding. So this would be like action on the inside. The very way that psychologists talk about this capacity in terms of attentional selection, I notice selection is doing something. So we've gone beyond transcendental idealism in terms of sense-making and illusions. We're now in the world of you are in charge of your sense-making. So we got this sort of, all the difference between seeing and looking is that look is a verb. But this also applies to internal mechanisms, internal actions. The reason and this is what basically this adversarial research.
Yeah, so your theory is more about doing versus IT is more about being.
Yes.
Yeah, but that's a nice distinction, a very clear distinction to make. I'm curious what happens when sort of we assume our behavior not to be sort of in a minimal state of doing, closing my eyes, sensory deprivation, these sort of experiments, right? Or for instance, psychedelics. So you lie down and, okay, very, very often there's music involved, but say you don't do that. And the experiences people then have, what can the free energy principles say about these experiments? Because it seems to be, so that's self-action, you would call that, action upon yourself, because the model then doesn't have input. But the model has to keep going on. Sort of, it keeps on reducing free energy, but there's not anything coming in. So what's happening?
Right. So there are two great answers to that, because I know we can also talk about psychedelics. And,
yeah, of course, that's nice to talk about.
If there's nothing coming in, how can you minimize free energy?
Yeah.
Now, the answer will be about 20 minutes ago when we said that evidence is equal to accuracy minus complexity. Mm-hmm. So in the absence of anything coming in the absence of any sensory information, say, for example, when we're asleep, when we shut down all our sensory organs and indeed our effector organs, then there can be no accuracy, because accuracy is an attribute of the sensory evidence or the sensory input, but there's still the complexity. So that means that we can, with gay abandon, reduce the complexity of our generative models while sleeping. Put that another way, in fact, invert it. Perhaps the fact that we sleep and the fact that there is so much selective, in an evolutionary sense, selective pressure for sleeping is that this affords the opportunity to minimize the complexity of our models. Again, coming back to Einstein, keep everything as simple as possible, but no simpler. So to get the right balance between accuracy and complexity requires us to discard overly complicated, overly complex, overly expressive, or over-parameterized generative models while we sleep. So we're now fit for purpose the next day, and we don't start to overfit our data. I should just say that just intuitively, why is it bad not to minimize complexity, or why is it good to keep things as simple as possible? If you just think about fitting data, say, in a statistics sense or indeed a machine learning sense, if your model is too complex, it's got too many degrees of freedom, coming back to the law of requisite variety. If it's got too many degrees of freedom, you're going to fit noise. This is known as overfitting. And it's devastating, practically when you're building transformer architectures, for example, or any kind of generative AI. Then, if you don't try to minimize your complexity in the right way, you will overfit and you'll never generalize. It just won't work.
Yeah.
So this complexity minimization is really, very important. And that's probably why we take ourselves offline just to rehearse. And one could argue, in fact, people do, that dreaming is this kind of rehearsal. The fundaments of the cause-effect structure that our generative models entail, such that we can remove the redundant, overly expressive parts of it, literally removing the synapses, the associations in our brain that embody those associations. I mentioned that just because also in a completely different strand of work, Giulio Tononi has a synaptic homeostasis hypothesis, which fits beautifully, with this view. Yeah. So that's, there's still a lot of measurement and inference and self-evidencing that can go on in the absence of sensory data. And just think about the way we work. We have to take ourselves offline. We have moments of introspection.
And if I may, but this is very speculative, and I won't sort of want to sort of, you don't have to commit to any sort of weird esoteric phenomena that I want to sort of just share with you. But I'm only curious if the free energy principle would, in principle, be permissive to the idea. And I'm talking about sort of just the phenomena, for instance, psychedelic states where people do have these. I've had that myself. It's interesting. I do think I had a sort of a very high degree of complexity with low accuracy, but a complexity I have never seen before, like a Van Gogh painting, pure beauty, but not accurate. Astonishing to experience. Other people sense that they can sort of connect to a mind at large or a spirit world, spirit entities. Whether we grant any of those sort of an ontic status of being real, what interests me is when we think in terms of a Markovian blanket, we can think of it sort of in a very physical sense, my brain, my sensory input. But could it be that sort of this whole free energy way of thinking could also apply here, that somehow a boundary gets more porous and we process the world differently, and it might even tell us something noumenologically, so what truly exists out there. What are your thoughts here, without sort of asking of you to commit to any of these?
Well, I'm very happy to commit. I mean, there are people who, asking themselves exactly that question. People like Robin Carhart-Harris and his colleagues, and also to a certain extent those philosophers. I'm thinking here of people like Thomas Metzinger, who make it, who have a certain take on qualitative experience in terms of the phenomenological aspects, in terms of transparency versus opacity. You can, I think, link all these notions together using exactly what we were talking about before in terms of your false modeling in, say, people who are subject to hallucinations and delusions. It's the balance of the precision, the credence afforded to the sensorium relative to your prior beliefs. So imagine what it would be like now to induce in yourself a kind of autistic state by taking a drug that chemically dissolves the precision of your prior beliefs, thereby relatively enhancing the precision of all your sensory inputs, and particularly the visual input.
Okay, check. So so I'm reducing the precision of my model, which makes that new input has to be sort of needs more attention, because I cannot assume that it's right. So I have to look closer. Is this microphone indeed what so you're resetting that in
well, it ceases to become a microphone, because the microphone is a really high level, deep illusion. It's like matter. It's a useful story you can tell yourself, and indeed I'm telling myself that it is a microphone. It has all sorts of functionality. But if you've dissolved this kind of narrative in your head, so when I talk about deep or priors, I have in mind a centrifugal hierarchy with increasing abstraction and scale. The representations as you ascend into the hierarchy and get deeper and deeper. So things become sort of much more elemental and short-lived as you get to the periphery, because the deeper layers are assimilating, gathering together, finding simple stories that explain a myriad, trying to compress things into a microphone. But this is not a microphone.
I like that the fact that you're saying the word, sorry to interrupt, but it's just, it's fast, it fires me up that you use the word compress. Because also an analogy I thought of when for this, in preparation of this conversation, is sort of the zip file in computer. People know we can zip images, and so the microphone is an extremely efficient zip file in my head that tells me this is a microphone.
Yes, yeah.
But if you would unzip it, there's no microphone, or it's something completely...
Precisely. Yeah, well, that's a great point. There's so many ways we can take this, but let's just pursue that, because I think that's a really important and fundamental observation. And interestingly, goes right back to the inception of predictive coding. So if you remember, we were talking before about predictive coding being one implementation of the free energy principle under certain assumptions about the kind of generative models that are being used. Predictive coding started in the 1950s as a way of compressing sound files. So there's a deep mathematical link between compression and complexity minimization and free energy minimization. Really, really deep. And that there's a parallel story that comes via Solomov induction from Kolmogorov complexity, and minimum description lengths and minimum message lengths, right through to universal computation. So it's exactly the same story. That the best inference to the best explanation, or the most efficient way of compressing or communicating, involves minimizing redundancy, that is basically compressing something into its simplest form, but not too compressed. So again, keep everything as simple as possible, no simpler. And it's exactly that balance between the complexity and the accuracy. And this, so sound file compression, and indeed I had an email exchange with Mike Levin a few weeks ago where he was going to use the capacity to zip compress his files in order to measure the complexity of the representation. It's a really powerful way of measuring the complexity part of the variational free energy. So in the context of you compressing all the information generated probably visually by your microphone into the notion of a microphone. So that compression is no longer available to you because you've dissolved by reducing the precision through neurochemical means, through taking, say, psilocybin, which is the 5-HT1A associated node, a particular receptor, partial agonist or agonist, that basically resolves the precision, the excitability, the credence afforded to these high-level, deep, iconic kinds of representation, which basically frees up and emphasizes the more elemental one. So this is not a microphone anymore. It's now an ensemble of objects, and each object itself has some remarkable features. And there is, a flat surface here that's reflecting some curious admixture of red and finer and finer detail. So you don't perceive the microphone, you perceive the elemental constructs that you would otherwise assemble into a microphone. And I think that's when you saw Van Gogh dissolving into elemental.
It must have been, and it's exactly what you say. On lower doses, when it does not completely dissolve, to me has been sort of the more pleasant experience, because I can sometimes notice that I have a rigid way of thinking, and then lower doses won't sort of get you to Van Gogh, but it will sort of let you reappreciate sort of the environment around you. Because in thinking about this a bit more normatively, and I'm curious how this works for you also on a personal level, what is sort of that ideal sort of model making, not to be too rigid and be porous enough, that level of being porous? What's the ideal level, if we can even talk about sort of what ideal is, because it's normative and we're talking about just what But I'm curious here.
Well, I mean, it's a really important question when it comes to simulating this. Indeed, using the free energy principle in application to simulate phenomenology, for example. There is a field of computational phenomenology or neurophenomenology. But the answer to your question is that the balance of the precision that we've been talking about, the balance between the accuracy and the complexity, or the priors and the sensory, the likelihood part of our generative model, itself has to minimize free energy. Itself has to minimize surprisal or maximize model evidence. So it depends very much upon the quality of the data that you are able to solicit from the environment. So I'll have a very different kind of precision weighting or configurational reliance upon prior beliefs versus sampling the environment if I'm in an environment that is unpredictable and imprecise. We could come back to the dark hotel room in which I have never been before. But you can imagine yourself in a dark city, a city outside walking on the pavement, in the dark, in a city where you've never been before. You've heard some awful stories about things. There are drug dealers near the station, and you don't know whether you're near the station or not. So this world is imprecise from your point of view.
Yeah.
So the normal deep abstracted microphone stories you tell yourself do not apply. Yeah. So now you're going to attend to the details. You're going to be attending. You're going to be on guard, vigilant, attending to all the elemental information that you can, and try and make as much sense. So it's going to be very, very context dependent. But there is an optimal solution if you allow optimality to apply to the free energy bound on just the evidence or the likelihood that you're in this state, given the kind of thing that you are. But you can interfere with that balance by ingesting certain drugs, and you could you'd say that certainly that's an interesting question to ask when it comes to addictive behavior. But psychedelics are not addictive in that sense. So, but they do have this remarkable capacity to rebalance, usually in the auditory, primarily the visual modality. This sort of balance between these deeply held convictions and prior constructs that we bring to the table to infer and summarize and compress our understanding of the world. But what I want to ask you now, what's the deepest, most abstract microphone-like construct that we use to explain our lived world?
So the deepest, like our whole world, the deepest model of our world.
Yeah, and what's right at the top? What's right at the center of these models? It's a trick question, but I know exactly what the answer that I want. Okay,
I'm going to give. I'm probably not understanding you fully correctly, but let's say that if my microphone reduces sort of the true complexity in the world to sort of a single thing I can grasp and think it must be. I'd say my best guess on a universal level would be something like God or the mind at large. Just a single a cause of everything. That I can then sort of, if I unzip it, I get sort of, I get to this world. That would be, I think, my answer to your question.
Right. So implicit in that, that was interesting. So in a Freudian oceanic sense, you gave me the example, the answer that I was groping for, which is the story that you are a self, the story that you are you.
Yeah.
So you are you, and you're part of some cosmos, and part of, so you use the word I about 4 times in answering that question.
Yeah. You're still a psychiatrist. Listening carefully.
I am indeed. So the reason I suggest that, so that you are part of something, but implicit in you are part of some something of this omnipotent or oceanic or unitary aspect, presupposes that you are a thing. So the notion that you are you, the minimal selfhood, or in fact the selfhood itself, is just another story under the free energy principle. So if you dissolve that, what would happen? Now there is no self. So now you have an explanation for non-dual states. So that sort of feeling that, if you're a very experienced meditator, you can actually aspire to with meditative practice, but also sometimes the depersonalization, which is actually in my experience, quite terrifying if you take too much of these, certainly psychedelics. The notion that you are no longer you, or there isn't a you, can be revealed through dissolving these higher level, or the precision afforded, these very, very high level explanations, best guesses about the causes of a sensorium, which I'm assuming is my sensorium. I'm assuming this is my body, and it is me that's doing the experiencing. So, but that can go away. We don't often experience that.
Yeah.
And clearly,
have you had, if I may ask, have you had?
I've had a similar, but not quite as distressing as I've seen in psychiatric patients who have deep episodes of depersonalization. On the other hand, I also, this is not necessarily a bad thing. You don't have to suffer. It doesn't have to be frightening. Or you've got, again, you have to ask yourself, how can you be frightened if you're not you?
There's no one to be frightened.
Precisely. So, but I'm really sort of speaking to this from in response to a question about consciousness.
Yeah.
If you're talking about self-awareness and self as part of your generative model, then I think you can usefully apply the free energy principle to ask questions. Well, what does that mean? What kind of generative model would you need in order to have a story? A microphone story. So the microphone, the concept of a microphone is just a story you use to explain this particular pattern of sensory inputs in a really useful way that immediately brings to the table all the affordances that are associated with a microphone. The same argument, though, is me, that I am just, another explanation like the microphone, which I learned and brought to the table. And I didn't arrive with it. When I was born, I didn't have any notion of me. And I didn't have any notion of mother. From my point of view, this was just some oceanic universe where I was nourished, or I learned that my needs were being met, and it took me months, days, months, weeks to work out that mother was separate from me, and that mother had intentions that weren't always a direct response of what I could sense myself doing. Well, where did myself come from? Well, if mother is a thing in her own right, then perhaps I am a thing in my own right. And slowly you start to develop a sense of self, which you don't necessarily always attain. If you've got severe autism, you might never actually get that theory of mind that rests upon this aspect of self-modeling. But you can revert back to these, and some people like to do this. And certainly people like Thomas Metzinger think that things like the non-dual aspect of minimally phenomenal experiences hold the key to an understanding of consciousness. If you can strip consciousness right back so there isn't even a self there, then that might tell you quite a lot about the nature of consciousness. And
would you agree that what then remains, if all models are gone, my experience has been sort of in some of these states that a lucid awareness, let's use the word awareness here, remains, that is actually exactly the same awareness I have right now, but it just lacks all these models of selfhood, which was like profoundly strange to experience, but it helped me to distinguish between that awareness and sort of the contents of that awareness, the qualia that keep changing and everything, but to see that as a sort of a constant. Then thinking back in my life, only in very infant stage, I cannot go back to that state of awareness. Remembering the state of awareness as a baby, I cannot go back so far. But as far as I can go back, that awareness has more or less been the constant or the same, which makes me an idealist by saying, okay, I suppose that is fundamental, and your theory to me is a brilliant mathematical way to describe the doings that happen within consciousness, the mechanisms at play in these models that model the contents of that, the contents of perception that present themselves to my awareness. What are your thoughts here? Would you agree to what I just described as awareness sort of being a ground, so to speak?
Yes. Yeah, I think you're very lucky to be able to experience that awareness without the content.
It's not a daily thing.
No.
It's a hard, and
and from what I know, I think people aspire to that through years and years of meditative practice to try and induce that. So
it has been on substances mainly.
Oh, I see. Yeah. Right. You should tell my meditator colleagues. They probably know
it's
already.
The shortcut. It's the yeah. But please continue. Yeah.
Yeah. So yeah. And I was struck by your I can't get back that far, to those. I keep using the sort of, and I'm sure I'm using it wrongly, sort of oceanic Freudian sort of, when you first arrive into the world, when you're not even you. Well, that makes perfect sense, because remember, from a Helmholtzian point of view, unconscious inference point of view, if you don't have the machinery, you're not ever going to be able to remember it. You can't perceive it. So just be able to perceive the world as being something that is you are constituted of. Is a remarkable capacity, which I repeat, may take a long time to develop. And then you were talking about the sort of the continuity. I think that's really interesting.
That is sort of more or less the same thing. That sort of as if say the model is of the generative model is sort of just giving me a screen of perception. It's giving me a dashboard, and we've been talking now a long time about sort of how that works, and it's absolutely fascinating. But there still seems to be and let's call that this awareness that perceives that screen of perception. That has always been the same, and it sort of will always be the same. That's how I see it.
Yes, and marks you out as a very high-level life form, I would imagine.
But it's also something you can more or less. This is what non-dual teachers, of course, teach in sort of like that you can arrive at that analytically. I say this mainly analytically. It's not like something but in thinking about it, I am able to experience it more often. But I'm curious here because we're touching on something that I think many people might misperceive your theory, because you could say that let's frame it like in a totally different way. Would you say that the free energy principle is matter doing all of this, and then it produces somehow phenomenal consciousness? Because that would be like the physicalist story. Then that would be like the physicalist framing of your theory. Just I start with the Big Bang, and I've just all the physics we know. And the free energy principle then starts just describing what cells do, but it still cannot solve the hard problem of consciousness. And somehow consciousness emerges. But that doesn't seem to me what the free energy principle is about.
No, I think you're right. Again, you'd have to think very carefully about how you would apply the free energy principle to the hard problem. And you can do that, and we can talk about the ways of doing that. That sort of notion that it is me watching a screen that is unfolding, I think it's really interesting. Certainly from a purely technical, non-philosophical position, that speaks to something which I think may be peculiar to things that can be attributed consciousness, and I'm denying panpsychism here as a plausible story. And that is agency. And if you just ask what it is to be an agent, it is something that has a natural kind that is sufficiently large that it can now entertain a generative model of the consequences of its actions. And I just slip in sufficiently large because, of course, we know our actions, if our actions are part of our Markov blanket. But that's not the case if I've got a deep generative model and some very deep Markov blanket right in the middle is a long, long way away from the actual muscles that I'm using to act. So now the action becomes technically a random variable, which means it has to be inferred. So now I'm in the game of planning my actions. I'm now an intentional agent. I'm an agent that has intentions because I'm now rolling out into the future to evaluate the consequences of my actions under my generative model. So what does that mean? Well, it means something quite profound. It means that you've got a generative model that is freed from the specious present or the current moment. It means you've got a model that is future pointing. So it's no longer, unlike a virus or a thermostat, tied to the immediate, now you've got representations of yourself in the future. And of course, if you've got representation of yourself in the future, you've also got a representation of yourself in the past. You as agent. And it's only your agency. It's not my agency or something else's agency. It's me, my future, and it's a path into the future, and therefore a path that comes from the past. So mathematically, if you're this natural kind, then you must have some Bayesian mechanics that speaks to this continuity over time and that equips you with the notion of an invariance over time. There is a past, there is a future. Not everything can have that. So, it is quite. So I just wanted to pick up on this. Quite important.
But you're also sort of deriving sort of the flow of time here and the mystery of time from the free energy principle, which I think is fascinating.
Yeah. Well, you should speak to Chris Fields about this, who insists that any plausible explanation has to be background free. And what he means is, if you start or Donald Hoffman is also telling us a very similar story.
Yeah.
And I would completely concur with these positions. Space and time, as we talk about them and read about them at school or in physics books, are just stories. They are just microphones. They're just things we bring to the table that provide a simple explanation for our lived world, which would go away if things moved around in relation to each other close to the speed of light. The notion of time and space that we currently have just would dissolve. It's a good story for our lived world, not necessarily all lived worlds. Is time part of that? I think it is, and I think we come back to where we started, which is this relational view of time. Yeah. How do you measure time? Well, how do you observe time? And the only way you can observe time is by the belief updating of something else that is an observer. So how quickly, technically, their information rate, the movement on a statistical manifold per unit of clock time, or how many different belief configurations do they go through for every one belief update that you do? And then you've got this notion now that there are going to be all sorts of time perceptions in a deep generative model, because every level is looking down the level below, thinking, oh, you've changed your mind 3 times before I changed my mind once. And then
this is a specious presence. Yeah, indeed. It's fascinating. Yeah.
So that was time, but there was something.
Sorry to interrupt you. It's just
we keep missing all these wonderful rabbit holes because we keep going down the
you were talking about Donald Hoffman, and that you
there is no space time or background free explanations. It has to be the case. I would certainly agree with that. We're talking about agency, and agency necessarily requiring a generative model that had this sort of temporal persistence aspect. Yeah. But there's an interesting tautology here, because remember at the beginning I said that the generative model is an explanation for things that possess characteristic states. And those characteristic states define a pullback attractor. But the pullback attractor is just defined in terms of things that endure during time. So it could, if you are modeling yourself as something that persists in time, you couldn't do it any other way. So to put it another way, if on the view of the good regulator theorem, you come to model you as part of your controllable world, because now in this hierarchical context there are bits of you that can be controlled, then by definition you have to have a model of yourself that persists in time, because that is the kind of thing you are, by definition, to exist. So there's another deep tautology here. It couldn't be any other way. So that sort of sense of persistence over time is just part of the story.
Yeah, what fascinates me that if we take phenomenology, so my experience of sitting here, my experience of seeing the world as sort of the only given that I can be sure of, that is the experience, that is, whether it's an illusion or whether that still is an experience. So that's to me sort of like a ground axiom of existence, so to speak. And we know from first principles, your theory, that we do not see the world as it is. We cannot see the world as it is. The combination of those two ideas at least seems to falsify or just give materialism a very hard time, because how can I sort of say anything sure about that outside world? And I just told you that my first axiom is that I experience the world. I do not. Matter is already a zip file. The idea, it's a model already, and in the whole predictive coding and neuroscience, it seems to be that there are many people who seem to miss this point, that if predictive coding and active inference, if you apply it to itself, you also have to say that itself is a model. So the model is a model. So I'm trapped in this model making. And the only thing I'm sure of is that there is a me experiencing all of this. Well, that in philosophy is called sort of idealism. But this, I think, is a cultural baggage we have of like a couple hundred years of science and physicalism, that people still think that this is compatible with materialism. But I'm so curious on your thoughts, because I do think you are also perceived as a materialist by many people, if I'm not mistaken. But
well, you would probably be in a better position to know than I would.
Yeah, at least that's sort of the perception. If I'm just doing my research online, people perceive it as a sort of a materialist way of looking at the world. I guess because you start with mathematics and as if you reduce the human to sort of mathematics, and I think people associate that with materialism.
Yes, although it is a particular kind of mathematics. It's a mechanics of belief updating, which is not a component of things like quantum mechanics or classical mechanics, or indeed integrated information theory. Yeah. It's a very particular kind of mathematics that lives in an information geometry, where this geometry is beliefs about something else. So we come right back to the original distinction between the noumenal and the phenomenal. Yeah. So, there's something unique about the free energy principle which you won't find anywhere else. But I'm tempted to ask you to tell me what a materialist is, but I'll pretend I'm not naive and assume it's the position that there exists some physical world out there
that can be fully captured in quantities that we can measure, and that can be fully captured in quantities. So whereas our experience of the world is qualitative, right? We do not. This philosophy. I mean, maybe that's a nice one. You might have heard of that. I think it's Mary in the black and white room. So say I'm in a Mary's in a black and white room, and she literally learns everything there is to learn about color, the wavelengths, everything. Of all colors. If she then exits the black and white room, having lived there all her life, into a world of color, will she learn something new about the world? Materialism would basically say no, because everything there is we can fully measure in these quantities. But of course, intuitively, many people say, of course, because the experience of color, the qualitative experience of color, is something completely different than the third-person perspective, the description of color. And if I say that's my definition of materialism, which I think in philosophy is sort of the definition of it, then I think it's just a naive position, considering my experience of the world combined with what science is now telling me, so active inference, but also quantum mechanics, that we cannot sort of draw this distinction between the quantities I observe and me and my observerhood.
Right. Then
do you still follow? Because I'm not a philosopher. I'm just very deeply researching all of this.
Yes.
Yeah.
Well, that makes you a philosopher, or at least a natural scientist.
Thank you.
So, no, I'm certainly not a materialist. Mary, in that instance, would certainly not perceive colour. She could certainly learn how to perceive colour if she was sufficiently young and neuroplastic. So, coming back to Helmholtz, you cannot experience anything unless it's already on the inside. But how does it get on the inside? You have to engage with the world across your Markov blanket, and it would take years before Mary saw colour, which has got nothing to do with her epistemic science book reading about the nature of colour. And then your statement that the world is fully observable, measurable. There is a metaphysical world that can be fully measured.
Yeah, in quantities that we can predict, manipulate, and that physics describes.
Then I am not a materialist. No, the whole point of the free energy principle is that there cannot be a fully measurable world. If there was, you would be part of that world, and by the principle of unitarity, you would not exist as distinct from that world. So if the fullness aspect of materialism is centre stage, then I'm certainly not a materialist. On the other hand, the maths that you would use to derive the free energy principle, which could actually be thought of as or you could apply to materialism in and of itself if you wanted to, does rest upon the notion that there does exist something that is not self. That's the observed does exist.
Yeah.
And you can actually sort of analytically, mathematically, and also numerically emulate self-evidencing and sense-making in a way without even talking about the basic mechanics. And in that setting, which is effectively teleology-free, what one arrives at is something called synchronization, or generalized synchronization, or synchronization of chaos between the inside and the outside. So that you can, from a purely dynamical systems perspective, say that the free energy minimizing solution just is when we've established a mutual entrainment and a generalized synchrony. I repeat, synchronization of chaos, because we're dealing with random dynamical systems. That are certainly for life forms chaotic in virtue of the technically the solenoidal flow, or the biorhythms and the cycles of life cycles, reproduction and the like. So that if materialism just means that there is some cause-effect structure of a probabilistic sort that is not uniquely owned by the observer or the self, then I am a materialist, because I have to have a mathematical image of the observed, the outside, the world. So in
that's more like solipsism, I'd even say. Right. For instance, I mean, idealism would not deny an objective reality out there. It's just not physical in the sense of only consisting of quantities that we can measure and thereby having fully captured reality by the measuring of those quantities. It wouldn't deny, because under idealism, an idealist, maybe nice to just bridge to sort of what people better understand would be like, of course, the ancient traditions that would start off in Eastern non-dualism with a one that is not matter, but more, or not more, but it's mind. It's sort of the mind, or the nothingness. I mean, it can also be nothingness, and out of which different selves emerge, right? And on all sorts of different levels, from gods to humans. And then in such a worldview or cosmology, to me is interesting, not for literally believing those stories, but it gives me a model of understanding our universe as a oneness that somehow, by dissociating itself or creating blankets, I don't know, I don't know how, but it somehow seems to be doing that. And why does it do that? That sort of the whole game of it all is this model making, and that therein lies the beauty. But now I'm leaving science and venturing into sort of even more like the poetry of it all, in a sense. I'm just curious how that works for you also, because there's actually a nice bridge. I read you on William James that you when William James, of course, wrote like more poetically in a sense about consciousness, and when he said, I quote you, just funny to reflect with you on it. When I hear attention is taking possession by the mind in clear and vivid form, so this is sort of like not accurate description of what happens when talking about attention or awareness, and you then say, I think, no, it's not. Attention is simply the process of optimizing precision during hierarchical inference. So I like that, because that's sort of the mathematician in you wanting to be accurate. in relation to something to William James here. But I'm curious about sort of the more poetic Karl Friston when pondering, looking outside. What are your more poetic notions of sort of the free energy principle and the meaning of life, even? Sorry for my lengthy questions, by the way.
I mean, one answer to that is that for me, maths is the highest form of poetry. So, I find beauty in the maths and the simplicity, of course, which brings us back to the complexity minimization, the right kinds of stories, the right narratives, the right calculus has to have that mixture of simplicity and accuracy. In a sense, a kind of oneness that you were alluding to. So my poetry is in the maths, I'm afraid.
Beautiful.
So,
I wish I could read that poetry better. I should have sort of studied.
Well, I think it's an interesting way to phrase that, because of course reading now speaks to the hermeneutics problem of understanding the meaning of the maths in relation to other constructs, and I think that's largely what our conversation has been about.
That's interesting. Yeah.
So
you're right.
It's
So you would agree that mathematics is what is about syntax. It's about a structure of reality, and I'm much more about the semantics. What all of this means.
Yes, and of course we've talked at length, try to unpack the semantics for our viewers.
Indeed. Yeah, and you're about the syntax. So
But, and that also speaks to a point that was covert in one of your previous questions, that the free energy principle is itself just a story. I think that's absolutely right. Very much like natural selection or evolution, the free energy principle sort of conforms to its own principles, in a sense, in that it provides a simple but accurate account of everything. Of the data available to us. And, in the same way that sort of, evolution has itself evolved, or evolutionary theory in terms of neo-Darwinism and sort of modern day syntheses, evolution has evolved. The free energy principle is just a principle that can be applied to itself. It just is meant to provide a beautiful and simple, in my world, poetic description of what people know, basically. Well, people are not materialists in the sense that you described know already, or have known since Plato. So that's certainly true. There was something you said which I just wanted to pick up on there.
The meaning of life.
So, under the free energy principle, the meaning really inherits from the notion of self-evidencing. So now I'm being poetic. So I'm pretending to be specifically Jacob Howie, who sort of has been one of the key people promoting the sort of self-evidencing aspect. So one can read active inference under the free energy principle as self-evidencing. So what does that mean? It means that I am just here gathering evidence for my model of my world, and crucially, because my model has this central notion of me in it, it's also a self-model. So I'm gathering evidence for my model of me in my world.
Wow.
Which just means, what would it look like? What would I? So what am I trying to optimize? What am I trying to do? I am trying to optimize the evidence. I'm trying to minimize the surprise. I'm trying to optimize the evidence for my model. So what kind of thing does that make me? It makes me into a curious creature. It makes me into something that wants to understand my world. It describes what you are doing now. Why are you doing what you're doing now? You are just trying to resolve uncertainty. You're on an exploration. You're an explorer in a particular intellectual and philosophical domain. You're not doing this to keep your temperature at 37.2 degrees centigrade or get chocolate or money. You're doing it because you're seeking meaning.
Yeah, it's so true. Thank you for that beautiful reflection, because like an hour ago when you asked me about sort of the highest model and I said God, and you accurately said, but I heard a lot of me, when I was talking about God, that it has a lot to do with me, understanding myself. So what I hear you saying, that it is about sort of self-knowing, and it's about sort of better understanding of self, and that somehow our universe goes through the process of doing that via market blankets and models, but that
and that we do together. A lot of this is co-constructed. A lot of this rests upon the shoulders of giants and communication. So this is not, it is not something that I would do or could do in isolation if I was on Mars by myself. It's something that can only happen in this sort of...
Of course. And I like also that beauty in your theory that the free energy principle is a theory of self, but it's also a theory of selves and how they interact, and that's what we see in Michael Levin's work, and that all to me is just very beautiful and fascinating. And thank you so much for this wonderful conversation, Karl. I really enjoyed it.
My pleasure. Thank you. I enjoyed it as well.
I'm happy to hear that. Yeah, thank you so much. And thank you very much for watching this video. We will put links to Karl Friston's work below in the description. And if you have questions, please leave them in the comment section. And we see you in one of our next videos. Thank you.